Today we're going to start solving systems of equations with the substitution method. Now, to solve a system of linear equations with this method, you will first solve one of the equations for one of the particular variables. Once you get that, then you will substitute the results you get from step 1 into the second equation. You will solve that, and then the answer you get will either be x equals or y equals, and you will substitute that number value that you find into the other equation because your answer must always be an ordered pair. So remember, you need both the x and the y coordinates. Here's an example. Notice that the second equation is already solved for y. That means that y is equal to 3x plus 4, so I can just substitute 3x plus 4 in place of the y. When I do that, I can rewrite the first equation. Now I have x plus 2 and no longer y, but 3x plus 4 is equal to 8. Notice that the y has been replaced. Now I only have the letter x. I can solve by using the distributive property and combining like terms. I get 7x plus 8 equals 8. I now solve for x, so 7x is equal to 0. Divide by the 7, and x is equal to 0. However, remember, that is only one portion of my solution. Now I know that the x coordinate is 0. Once you do that, since we know that x is equal to 0, we can take the second equation and substitute the 0 back in place of x. So I have 3 times 0 plus 4, and that will give me 4 as the y coordinate. So you really are basically finding two answers to get the one ordered pair solution. This solution should check in both equations. Now in this second example, notice that I do not have any variable solved already. It would seem to me easier to solve the second one. If I solve for x, then what I would need to do is add the 6y to both sides of that equation. And I get x equals 6y. Now I can take the 6y and substitute that in for the x in the other equation. So here is what we'll have. Instead of 4x plus 5y, we'll have 4 times 6y plus 5y equals 0. When I multiply and add my like terms, I see that y is going to be 0 in this example. But remember, that's only half of the answer. The answer is a complete ordered pair, with 0 being the y coordinate. So we will now take the y equals 0 and choose either equation you wish. It would be easier just to choose the second one. And we will substitute in the 0 for the y. When I do this, I notice that x is also equal to 0. So the complete solution is 0, 0. Hope you see how substitution can help you out when solving a system of equations.